Hello students, welcome to AriserTalent. I am your math teacher Arpita Sharma. In previous session, we have studied questions related to rational numbers. Okay, and I've told you to solve this question. Let's solve this together. Without actually performing the long division. State whether the following rational numbers will have a terminating decimal expression or a non-terminating decimal expression. Whether terminating or non-terminating. Now, first you have to find that is one of these. Let me talk about this first. Okay, so first what you have to calculate that whether this number is rational or not. If rational, then you have to find that it's terminating decimal expression or non-terminating decimal expression. We have discussed all these kind of things in our previous session. So, let's start with the first one. 13 by 3, 1, 2, 5. Now, in previous lecture, what I have told you that P by Q is a rational number if Q is not equals to 0. Now, P by Q is terminating. P by Q is what? Terminating if Q is in the form of 2 raised to power n and 5 raised to power m. So, in denominator, if there is multiple of 2, either multiple 2 or multiple of 5 or multiple of both, if there is an equation something like this, then is expression something like this, then we'll call it as what? Terminating. And if not, then it will be non-terminating. Okay. So, this is our denominator. So, we have to be focused on this denominator. We will factorize it. We will factorize the denominator. We will factorize the numerator. Then we will cancel out the common terms, and even after cancelling out the common terms of 13 and 3125, if there is something more multiple other than 2 raised to power n and 5 raised to power m, then this will be non-terminating, and if not, then it will be terminating. Okay. 13 is a prime number. So, we will write 13 as it is. Now, 3, 1, 2, 5. 5 to 7, 1, 8, 9, 10 and 11. So, it is not divisible by 3 and not by 2, obviously by 5, 6 times, 2 times, 5 times, again by 5, 1 time, 2 times, 5 times, again by 5, 2 times, 5 times, again by 5, 5 times, again by 5, 1 times. So, 1, 2, 3, 4, 5, 5 times 5. So, we will write it in this way, 5 raised to power 5. That's how we used to write it. Now, I am rubbing this. Now, look at the denominator. We are having 5 raised to power 5 here. So, it is in the form of it is in the form of 5 raised to power m. So, we have studied either in the form of 5 raised to power m or in the form of 2 raised to power n, because if we are having something in denominator in 5 raised to power m, we can convert it into 5 raised to power m and 2 raised to power n by multiply it by 2 raised to power 5 and here also, so it will eventually convert in the form of 2 raised to power n and 5 raised to power m. So it will be what? Terminating. So for now we are only detecting whether it is terminating or not. So it is terminating, right? So it is terminating. Now question number second one, 17 by 8. Now 17 is the prime number, so we'll write 17, and 2 can be and 8 can be written as 2 multiplied by 2 multiplied by 2, that is 2 to the 4 to the 8. So it will be 17 upon 2 raised to power 3 here. So it will be again what? Terminating. Now the third one, 64 divided by 455. Now 64 can be written as 2 to the 4 to the 8 to the 16 to the 32 to the 64. You can write this expression as you used to do, like this. Okay, eventually you will find it like this: 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 30 to the 64. So this is the prime factorization of 64. Now 455, 5, 5, 10. It's not obviously divisible by 2. Okay, so now 5, 5, 10 plus 4, 14. Now 14 is divisible by 3? No, so it's not divisible by 3. Now 5, yes, we have 5 here, 5, 9 times, okay, 1 time. Now 91, it will be divisible by 7, look it, okay, 1 time, 3 time. Now 13 is again a prime number, so we will write it like this: 5, 7, 13. Now we are having this 7 and 13 in addition to 5. Now look at here, can we cancel these terms with this? No, we can't cancel it. So it will remain like this only. So what? It is not. Okay. Now this one, fourth one. Fourth one is 15 by 1600. Now factorization of 15 are nothing but 3 multiplied by 5. Now can I write this as 16 multiplied by 100? Okay, how can you rewrite it? How can you write 16? 2 to the 4 to the 8 to the 16. Okay, now factorization of 100, we have 2 zeros, so 2 raised to power 2 and 5 raised to power 2. So it will eventually become 3 multiplied by 5, 1, 2, 3, 4, 5 and 6, 2 here and 1, 2, 3, 4 here. So 6, 2 raised to power 6 and 5 raised to power 2. So look at this, 2 raised to power 6 and 5 raised to power 2. So it is in the form of 2n and 5m. So it is again terminating. Fifth one. Fifth one is what? 29 by 243, 343, right? So we'll solve this. 29, is it divisible by 7? No. 11? No. 13? Indeed, it is a prime number. So we will write it like this only. Now 343, 3, 3, 6, 4, 10, not divisible by 3, not divisible by 5, divisible by 7. Let's try 5, 4 times 28, 3 remaining, 63 9 times. Okay. Now 7 times, again 7 1 time. So it will be 7 multiplied by 7 multiplied by 7, that is 7 raised to power 3. Now is this a prime number? So now is this a terminating number? No, because it's not in the form of 2 raised to power m, 5 raised to power n, right? So we'll write it here. Fifth, 29 by 343, that's nothing but equals to 29 7 raised to power 3. Okay. We have these 5 results. Now what I am going to do, I am just writing the solutions that we have done in this side. Okay. So it will be first 13 by 3125. Why we are doing this? Because we will utilize it in our next question, 5 raised to power 5. So first copy it. I am going to rub it. The second one, that will be 17 3 raised to power 3. Okay. Then the fourth one, 15 divided by 1600, that's nothing but 3 multiplied by 5 to the power 6 and 5 raised to power 2. Be active. Do the next one. 29 upon 343, 29 by 7 raised to power 3. It is not. Now the sixth one. The sixth one. This is 23 upon 2 raised to power 3 and 5 raised to power 2. How good? It's like very good. This question is itself representing it in 2 raised to power n and 5 raised to power m. So you have to do nothing. Okay. So it is a what? Say terminating one. Next, 7th, 129. Now look at this, 2 raised to power 2, 5 raised to power 7 and 7 raised to power 5. So you can look at it and you can say, even if you factorize 129, you can't eliminate 7 raised to power 5. So it's clear that it is non-terminating. So 129 by 2 raised to power 2, 5 raised to power 7 and 7 raised to power 5 is not terminating. Now moving forward, we have the 8th one, 6 by 15. How can we write? 2 multiplied by 3 and 5 multiplied by 3. Now look. Why? Because I am having here denominator not as 2 raised to power n and 5 raised to power m, but I am having this 3 common in numerator and denominator. So I will make them co-prime. So what will it become? 2 by 3. Sorry, 2 by 5. So again the denominator is in the required format. So it will terminate. Then the 9th one, 35 by 50. How can we rewrite it? Time factorization now. 7 multiplied by 5. Now how can we rewrite? 5 is 5 and 2 is 2 multiplied by 5. We cut 5 by 5. Now we have 7 by 5, which is again what? Terminating in nature because of its denominator. Now the 10th one, 77 upon 210, right? So So 77, we'll factorize it. 7 one time and then 11 one time. So what are the prime factorizations of 77? That will be 7 multiplied by 11. Now 210, that will be 2, then 1, 0, 5, then 5 plus 1, 6, so divisible by 3. By 3, it will be 9, 1, okay, 5 times, then 5 times 7, then 7 times 1. So what we will get? 2 multiplied by 3 multiplied by 5 multiplied by 7. Now look at this, that 7 cancels out, but we have 3 remaining in denominator other than 2 and 5. Other than multiple of 2 and 5, we are having multiple of 3 here. So it is not a terminating number. So we have found that the number 1, it was terminating, it was terminating, it was terminating, it was not, it is terminating, it is not, it's terminating, then again terminating, and it is not. Now this is the question number 1, very first question of exercise 1.4, and the next question is, why I am not rubbing it? Because next question is, write down the decimal expression of those rational number in previous question. This was the solution of previous question, okay, above which have terminating decimal expression. So now we have to pick only the ones that were having what? Terminating expansions. So terminating was, writing from there, that will be 13. Okay, we have done the process from there. Okay, so I will not write this term, I will write this term. Okay, look carefully, I will not write this first term, that is 13 by 3125. I will write 13 upon 5 raised to power 5. That means the final factorization. So first was the first was 13 upon 5 raised to power 2. Now coming to second, that was again terminating 17 raised to power 3. If you know how to calculate it, how to convert it in decimal, do it before me. Then third was not terminating, fourth one was terminating. Fourth one was 3 multiplied by 5 and raised to power 6, 5 raised to power 2. Then the fifth one was not terminating. Then the sixth one, 23 and 23, 2 raised to power 3 and 5 raised to power 2. Okay, so I am rubbing this part now. So let's begin. How we used to write, how we used to convert the decimal expression? We will have multiple of 10 in denominator, right? We have done it previously in your previous classes, right? So to convert it, this particular denominator, to convert it in multiple of 10, what you have to do? You have to multiply 5 with 2, you will get 10. So here you are having 2 times 5. So you will multiply it 2 times by 2. So that will be 2 raised to power 2. So if you have to do it 3 times, you will be multiplying it by 2 raised to power 3. So when you are going to multiply denominator by some power or by some number, so by balance, so to balancing the denominator and numerator, you also have to multiply denominator with the same number. Okay, you know this. Now we will do it and understand it in a better way. 5 raised to power 2. Now I will multiply the denominator by 2 raised to power 2, and also to equalize it, to balance it, I will multiply the numerator also with 2 raised to power 2. Okay. So what will it become? 13 multiplied by 4, that will become 10 raised to power 2. Now 2, 5, 52, that will become 0.52. Okay, so the first factorization 13, 5 raised to power 5. So what we'll have to do? We'll just multiply it by 2 raised to power 5. Okay, now because we have multiplied 2 raised to power 5 to denominator, so we'll also have to multiply it by 2 raised to power 5 in your numerator. Now it will become 10 raised to power 5. Now 13 multiplied by 2, 2, 2, 2 and 2. 5 times 2, 4, 8, 16, 32. So it will be like this. Now again solving it. (13) and 32 will have 6, 9 and 32. It will give you 11, 4. So it will give you 416 multiplied by 10 raised to power 5. So how will you write it? 4, 1, 6, 1, 2, 3, 4 and 5. So your answer will be 0.00416. Okay, this will be your answer of first expression. Now the second one. 17 divided by 2 raised to power 2. 2 raised to power 3 can be rewritten 5 raised to power 3, and here again 5 raised to power 3. So 17 as it is. Now 5 raised to power 3 is nothing but 5 5s are 25, 25 5s are 125. 17 multiplied by 125, and in denominator you will have 10 raised to power 3. Okay. Now multiply 125 by 17, 35, 17, 8, 125. You will having 5, 12, 1, 2. So you will be having 2125 divided by 10 to the power 3. So you will be getting 0.22125. 1, 2, 3, 3 place. So it will be 2.125, your answer. Now next, you are having 2 raised to power 6 here and 5 raised to power 2 here. So how many 5s you have to add? 4 5s you have to add. So you will multiply it by 5 raised to power 4. So 3 into 5 Now 5 raised to power 4 and 5 raised to power 4. Okay. Now it will become 10 to the power 6. Now solve this. Now solve this. 15. Now this will be what? 5, 25, 125, 625. 625. It will become what? 625 multiply by 15, 25, 12, 31, 625, that will become 7, 3, 9. So it will become what? 9, 3, 7 and 5. Okay. So 10 to the power 6. So it will become 0, 1, 2, 3, 4, 5, 6, 0.009375. That will be your answer. Now, next, that will be equals to 23 raised to power 3, 5 raised to power 2. So you have to multiply it by only 5. That will become what? 15, 5, 1, 10, 11. Okay. Now this will what become? This will become what? 10 to the power 3. So the answer will be 0.115. Okay. 6th, 7th, it was not a terminating one. Then this one, right? 6 by 15. How will you resolve it? How will you write in decimal form? 2 by 5, you just have to multiply it by 4. Sorry, multiply by 2 and again here by 2. So it will become what? 4 by 10, which will become 0.4. Okay. Now here, I'll cancel out 5. Okay. So it's not 7 by 5, it's 7 by 10. Correct it. It's 7 by 10. So how will you write 7 by 10? It will be 0.7. Okay. The 10th one was again non-terminating. So this question solves here, completes here. So our first answer is here. The second one is here. The third one, it's here. The fourth one is here. This is the next and the next is here. Okay. So you understand the process? Now, this is the next question. The following real numbers have decimal expressions as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about prime factors of P and Q? Okay, it's not prime factors P F Q, correct it. It's prime factor of Q. Okay. Okay. Okay, students. So try to solve this question by your own. in next class we will solve this question and some questions, some mixed questions or all exercise. Because what happens in your exam, you do the exercise number 1.1 first, then 1.2, then 1.3, then 1.4. Now what happens in a particular one exercise, you are having only one kind of question. In particular second exercise, you will having only one kind of question. But in exam, you are not having this, that this particular question is from point 1.1 exercise or 1.2 exercise. Now you have to identify. You have to identify. So now what we will do in our last lecture, we will have some mixed questions from this and this and this exercise and we will solve them. Okay, keep watching. Thank you.